Hello, this is a tutorial for Qt signals and slots. We are following the YouTube tutorial how to use signals and slots. So in graphical user interface programming, we often have events such as button has been clicked, right mouse click, a pop-up menu has been opened, etc. So those would be events. In QtSpeak, those are signals. And then when that signal is fired or raised in QtSpeak, then a method is called. That method is called a slot. In other programming languages, such as in C#, signals would be events, and then slots would be the event implementation. So a method. Okay. Signals have a signature, and signals can, once raised, trigger, so can be connected to other signals, which will then be raised, emitted, or you can connect a signal to a slot, or you can connect a signal to a C++ lambda function. In order to emit a signal, you use the emit Qt keyword. And there's a special syntax for connecting a signal to a slot from the base Qt type QObject. There's the method connect. The implementation, so the slot, might be a method, so a function of a object instance, might be a static method, might be a free function, etc. A signal can be connected to multiple slots, but also a slot can be connected to multiple signals. So in this example, we have signal 1 in object 1, which is connected to two different slots in object 2 slot 1 and slot 2. Okay. So I'm on a Linux operating system, Ubuntu 23.10. I have installed using the Qt online installer the latest version of Qt, which is Qt 6.6.0. And the latest version of Qt Creator, Qt Creator 12. Let's open Qt Creator and create a project. So from Qt Creator, you go File, New Project, Application Qt, Qt Console Application, choose. This is going to be named Signals and Slots. CMake. No translations. No version control. In Edit, Control 2. In left sidebar Alt 0, I'll switch from File System to Projects in order to see the CMake projects, the CMake structure. with its targets. Next, we will create two classes, two C++ classes. So this is C++ source code. One class will be called the sender and the other receiver. Both will inherit from QObject. So add new C++ class, sender, base class QObject. Another one. Receiver, base class QObject. Now Qt Creator is at a new version 12. It has automatically added to cmakelist.txt add executable the new files that we have just created using the new class wizard. So sender.h, sender.cpp, receiver.h, receiver.cpp. If your Qt Creator is older, you might need to do adding lines 17 and 18 yourself by hand. Now we'll need to edit our classes. First of all, sender.h. We already have on line 12 signals colon. So we'll add a signal. So void action performed is similar to the signature of a C++ method. But then we should not have any implementation for this signature. So we should have void action performed in sender.h, but in sender.cpp, this should not have a function body. So with this, we are done with the class sender. Let's go to the class receiver, receiver.h. We will want our application to do something, and for that we will use debug log lines, and we'll use the standard Qt framework qdebug. Okay, so sender.h defines a signal which is similar to an event. These things get raised or signaled, and then we'll need an event implementation inside of receiver.h. Those are slots, so we'll use public slots. So this uses Qt keywords. You can disable Qt keywords if they conflict with other identifiers or other third-party libraries. Okay, using such a line, if you use CMake, so target compile definitions, private Qt no keywords, or if you're using qmake, you go config plus equals no keywords. And then you replace the Qt MOC keywords, signals, slots, emit with qsignals or qsignal, qslots or qslot, and qemit. So this is all uppercase and with underscore. So q underscore signals, q underscore signal, q underscore slots, q underscore slot, and q underscore emit. Okay, back to Qt Creator. So we have the receiver, which has the event implementation, which is a slot. So we go public slots and then the signature on action performed. No arguments. Okay, so this is a method declaration, does not have a body yet and should have. For this we use the features from Qt Creator, which is refactor add definition in receiver.cpp. Okay, we'll implement a simple body for the slot. So we already have qdebug header included in the .h file in here. So we'll use one of the functions there, qinfo. So qinfo is actually a macro that expands to this. If you hover on it, it will try to guess to what C++ source code it expands to. In here where it says expands to, this part. Okay, executing slot. Okay, so this is the current object, which is of type receiver, which inherits from QObject. That's why we can use the less than, and then this. So we have a signaler slot. We do not have any connections between them, so we need to create it. We'll do it in the main function of the executable. Okay, so we're inside of main. We have two classes, but they're just compiled, not used. We'll need to instantiate one object for each of the two classes. So for that, we'll need to have access to their .h file. So there's sender.h. Okay, fair enough. Not use angle brackets, but use double quotes. And this one is the receiver. And we'll create objects. For sender and for receiver. And then on line 12, we will connect the sender with the receiver. So the signal from sender will be connected to the slot from receiver. Okay. We will use the connect method, which is defined in the Qt framework's base type, which is QObject. So QObject is included like this in our current program. So we include QCore application, which includes QCore application.h. which includes QObject. Okay, so we have access to QObject. And then the connect method is a static one. So we use the type QObject and then : connect. And we want to use the signature that has 4 parameters: const QObject pointer sender, const QMeta method reference signal, const QObject pointer receiver, const QMeta method reference method. And then type is auto connection. So this is the signature that we're after. Okay, so sender needs to be a pointer to QObject. We have such a thing. It's sender, the local variable. Okay, so we need a reference to this, to action performed. So that's reference. The type is sender. Action performed. And then we need a pointer to the receiver, which is the local variable receiver. And then a reference to the method on action performed from the receiving class. So receiver okay. So with this, the 2 objects are connected, but nobody is triggering the event. So the signal is not emitted. We'll need to emit it. We'll emit from here, from the main function. We already have access to QDebug via the receiver.h. So let's use QDebug. And we use the keyword, the Qt keyword emit. Who should emit? Action performed, which is the signal. So sender action performed. Let's run the application. Make sure it compiles okay. It ran semi-configured correctly, compiled okay, and this is the application output. First, on line 18 from main.cpp, this debug log line is written. And then from receiver.cpp, the body of the event handler of the slot, so line 9 on file receiver.cpp, we create a new debug log line which says executing slot from and then receiver. And then these spaces are not necessary. Control S, run it again. And now we do not have a double space after from, as we did the first time. Okay, so this command line application never stops because it starts the Qt main event loop with a message pump and everything else. So that's why after you run it in Qt Creator, you'll need to actually stop it by using the stop running program button. Okay, so this is the simplest way of implementing Qt signal and slots using a signal definition, public slots, a slot definition, and then the body of the slot. So other more advanced scenarios would be for a signal to be connected to another signal, or for a signal to be connected to a C++ lambda. Okay, let's now look at the magic that Qt performs behind and underneath those Qt keywords and Qt macros. So this is the blog post, woboq.com/blog/mock-meets.html, where it shows us a bit of what MOC, the executable, does. So MOC is an executable part of the Qt library, handles the Qt extensions over the C++ source code, offers introspection, reflection, Qt signals, Qt slots, Qt meta object, runtime inspection of Qt properties, list of Qt objects, etc. Needed also for QML, or the advanced machinery that surrounds properties, such as observer patterns, etc. Okay, and mock is run on the source code, on the C++ and C++ source code files as part of the build. But it says that it does not touch the files that we wrote. So what does that mean? It means that it's not like a preprocessor takes this file and converts it to another .h file, and that then it runs the C++ preprocessor on it, and then it runs the actual compiler on top of it. So the mock does not touch this file. This file is a plain C++ source code file, which is compiled the way C++ source code files are, which means this file is included in here and in here, in these two translation units. And then all of the macros are expanded, etc. And then all of the three translation units that we have, main.cpp, receiver.cpp, sender.cpp, are compiled, and then they're linked. Okay. So QObject is indeed a macro, but a very standard C++ one. It's just expanded here. Signals is a macro. So it's public attribute annotate Qt signal. public is public from C++, slots is attribute annotate Qt slot. Okay, so they don't do much. But then MOC creates additional C++ translation units. So our source code project does not have just these 3 translation units that you would expect, the 3 extensions with files with extension CPP. There's also the files, the translation units, source code files that are created by MOC. Let's look at those. So this is where the source code that we wrote resides. So CMake list was created by Qt Creator. Parts of main were created by Qt Creator. Receiver.h.cpp, sender.h.cpp were created by us using Qt Creator's wizards, and then new class wizards, and then we've changed them a bit. And then the MOC has created files in here. So in the parent directory of our project signals and slots, it's this directory with an ugly name. And in there are the files generated by CMake configure step, by CMake generate step. If we build using CMake, which we do, in here will also be the binary files. And in here, in EWEIEGA46WW, we have the files with mock in name, which were generated by MOC, Meta Object Compiler. Okay, so there's 2 additional translation units. Let's actually do a full rebuild. So build, run CMake. Let's clean. Build, run CMake. Build, Control B, so this thing rebuild. Compilation output. And we can see the translation units. So it says, let's clean this up. Build, rebuild. So after it does clean, then it does build. So build means running the Qt executable, so MOC, UIC, and maybe the other one for the files on top of the files that are part of our project. And then it runs the C++ compiler cxx for sender.cpp, so for this thing, for receiver.cpp, this thing, for main.cpp, this thing, and also for this hidden one, which is mock compilation.cpp. CMake files, signals and slots dir, signals and slots autogen. So this is the 4th translation unit built into an object file, mocks_compilation.cpp.o. And these are the .o files for the translation units that we can see in Qt Creator. And then the linker creates the executable with the correct name, signals, and slots by combining the 4 .o files. So these 3 O files and this one. Okay, and the executable is put in the top level directory so in the directory where CMake does its things. It's this one, signals and slots, the final executable. Okay, so now let's look at the MOX compilation CPP, so the two generated files, and compare them to their pair. So sender is the first one, mock sender.cpp, which is the pair of this file. So all of these lines were generated using the wizard from Qt Creator Integrated Development Environment, new class wizard. This was the part that we added. We said that this C++ declaration should not have a body. Why? Because the body is here. In mock underscore sender.cpp, it says signal 0 and the correct signature, so sender : action performed. So these are additional bodies for the methods that have been declared here. So in here are declared, I know, 100 methods. So this is one. And then in here, there's a ton of them. So 1, 2, 3, 4, 5, 6, etc. So all of these need a body, an implementation. So there's the implementation for sender action performed. Qt metacast, so virtual void pointer Qt metacast const char is this one. This is the body. And then for virtual int Qt meta call q meta object call int void pointer is this body, etc. So the body of the signal just calls activate with this, and without a second, so a third and fourth parameter. Okay, so this is the meta object part. There's action performed stored in a I'm not sure what this thing is. So it's a very efficient way of storing metadata about the signal action performed. So its name, there are some integer indexes. This is also called signal 0. Okay, and now let's look at the other one, which is receiver. We have both a signature and a body, a definition. So in here, we only have the metadata. So this part. And then so it says receiver, which is the name of the class, on action performed, which is the name of the slot. And in here also. And then the rest are bodies which are required by Q underscore object. Similar to what happens in mock sender. Let's actually compare them. So they're just boilerplate. The implementations, the bodies of the functions which are declared using Q underscore object are extremely similar, if not identical. The only thing that really changes is the name of the C++ class. You can see them in with a darker blue background. Okay. There's Q meta object invoke meta method, and additional for the sender, which has the signal, there's this else if Q meta object index of method. So this exists in the sender, does not exist in the receiver. The receiver does not have any signals. Okay. In here we have the slot, and in here we have the signal. The sender has signal, and the receiver has slots. There's a count of signals. Okay, and this is the meta data, the meta object. The information needed for reflection. Let's also exemplify with a Qt graphical user interface application. So for that, we are using Qt Creator, create project of type Qt widgets, choose the directory, signal slot, CMake, main window is okay, no translations, no version control. Let's edit a bit the UI, have a button and a label. Okay, no need for a status bar, no need for a menu bar. Let's lay out in a grid. Save everything. So let's look at the source code right now. So we have a long cmakelist.txt with support for different operating systems. There's the sources. The executable. Okay. Then we have the main.cpp, which is the entry point of the executable with its main function. There's the main loop, declares an application and a window. And then we have main window.h and main window.cpp. So we can create a signal and a slot and connect those. So the first signal will use the push buttons clicked signal, and we will need to create a slot for it. Okay, so we'll do it in main window.h. We'll put it in here, a new slot. So a slot being a signal, an event implementation, event handler, slots, this. Void on clicked. We'll use refactor a definition in main window.cpp. And in here, when the button is pressed, we'll just change the label. The button was pressed. It's clicked. Okay, so we just defined the event implementation. We did not yet connect the existing signal with this new slot. What's the existing signal? The existing signal is the one from the push button. So this is the push button, which is named push button, and this is the label, which is named label. Okay, so let's connect signal and slot. We're going to use the same connect overload that we used before. So this has 4 parameters: who sends, the push button, what, queue push button clicked, who receives this, and the reference to the method onClicked. Let's see if this is enough. And is enough. So just an event implementation, which is called a slot, and then the connection between an event and an event implementation. So the connection between a signal and a slot. Okay, so the signal for queue push button clicked is declared not in the class QPushButton, but in the class QAbstractButton, which QPushButton inherits from. So QPushButton inherits from QAbstractButton. Okay, so this was the simple scenario where we have a signal, we've connected it to a slot. What if we want to connect a signal to another signal? For that, we'll create a signal in our main window class. Okay, so let's create a signal. Void, and this would be intermediate signal. Okay. Again, we do not need to put a body for this method because the meta object compiler will create one for us. Now we can start connecting it. So this was the first connection that we had from the push button straight to the on-clicked. So let's use that intermediary. Okay, so starts from Q push button, goes to main window, the intermediate signal, and then starts from this thing. To this and on-clicked. Let's see if it works. And it does. So if you break the connection somewhere, it stops working. Okay. Okay, let's create. So this used to be a two-step thing. Now it became a three-step thing. Let's make it become a four-step thing. So let's put in this chain of events, let's add a second slot. So void intermediate slot. Let's implement it. Okay, and what we want this to do is to emit. So emit is a cute keyword, which is in fact a macro. Okay, a C++ macro. And we're going to, okay, so we're doing, this is the first, this is the second, then we're emitting the third, which is this one. And the fourth is this. So let's hook it up together. We start from the push button. So this is the first. We continue with the intermediate slot. The intermediate slot continues with intermediate signal. The intermediate signal continues with on-clicked. So clicked, intermediate slot, intermediate signal, on-clicked. Let's see if it works. The button was clicked. So this is an event implementation that triggers another event. Okay, so this is a slot which emits a signal. So let's look at all of these. So we have four things. The first is a signal. says in here it's a signal. The second is a slot. It says in here that it's a slot. The third is this thing, intermediate signal, which is a signal. And then the signal is connected to another event implementation, so another slot. We can see it's a slot in here. Okay, another thing that we can do is to connect a signal to a slot, that slot being not a method, so a function of an object, but a static method, which is a function of a class. So in here, in slots, we'll have static void onClicked. Okay, we do not need this thing. We do not need this thing. And like this. We do not have access to this. UI is part of this. It's a private a field of main window. We do not have access to the fields of the object of type main window. So we do not have access to this thing. And also the object that receives the object that contains the slot does not exist. We just delete it. So let's look again. We do not need the signal. We need slots, public slots. We need onClicked. And when the push button is clicked, we are executing the slot onClicked. Okay, so since we cannot change the user interface that we have because we're in a static method, I've created a queue message box. So let's see how this runs. When I push the button, a message box should appear. Okay, the button was clicked. What else can we do with signals and slots? If we have if we emit a signal with more parameters, so with more arguments than the slot that receives that signal, that's okay, as long as the slot has 0 arguments, or the arguments are the first arguments in the definition of the signal. So signal should have more, slot should have less or identical. Let's create an example of such a thing. Okay, so we reverted the application to what it was before, when we had 2 signals and 2 slots. So signal, slot, signal, signal, slot. Okay, what happens if we emit a signal that has many parameters? Let's say the intermediate signal has 2 parameters. What could they be? X and Y. So an event is triggered and the event wants to say that the X is 1 and Y is 2. The event implementation has 0 arguments, so it just discards those values for the arguments X and Y, the 1 and 2. The event implementation is not interested at all in the arguments that are being passed. So that's valid. No data is lost. The Qt framework knows how to wire such scenarios with a signal with arguments and a slot with 0 arguments. Let's see that it works. The slot requires more arguments than the signal provides. So on line 12, it was intermediate signal instead of intermediate slot. That was the error. So this was a slot with 2 intermediate signal has 2 arguments, and clicked is also a signal but with 0 arguments. So you cannot do that. You cannot go from less arguments to more arguments. Whereas this has 0 arguments, this has 0 arguments, this has 0 arguments, this has 2. There's not a problem, we just call a function, we emit. But then the number of arguments decreases from here, so here there's 2, whereas on clicked has 0. So 0 arguments, 0 arguments, 2 arguments, but we use emit. And then the number of arguments decreases again, so 2 and then 0. Okay, we can see it works. Okay, and then we said that if we emit a signal and that has 2 arguments, that can be handled by a slot that has just 1 argument, but the argument should have these signatures, so should be int. So this thing, int this thing. Let's see if it compiles. It should work. And we can also see that the value is actually 1. So we're setting the text of the label to the text, the button was clicked, and then the value is this 1. So we expect to see the value is 1 in here. So let's see. And it is, the value is 1. If we make this thing 100, it's 100. So we can go from more arguments towards less arguments. So this is 2 arguments and this is 1 argument, and they're connected in here. We cannot go the other way around from 0 arguments to 2 arguments. So this should be it. This is how you use Qt signals and slots in the Qt framework. Thank you.